6.11, derivatives of inverse functions. So an inverse, we don't talk about a whole lot, but we did do it in pre-calc. An inverse is where x's and y's swap. So let's say I have a function that has a point at 1, 2, 2, 4, 3, -5. What happens is in the inverse, which is denoted by f -1 of x, they would swap and have a point at 2, 1, 4, 2, -5, 3. And there was a way that we went to check to see if, say, f of x and g of x were actually inverses. We would do what's called a function composition, or remember FOG. FOG, this is really a composition symbol of f of g of x and g of f of x. We would take one function, put it into the other, and they should always equal simply x. That's how we would check. And so here's where the inverse derivative formula comes from. This says that the function of its inverse function, composition, always equals x. So here's plugging in its inverse into a function, and it equals x. We're going to take the derivative of both sides. So I've got this d over dx of this part and of this part. This would be a chain rule. So the derivative of f would become f prime, keep this the same, times the derivative of f inverse. So you can't really see that. And then the derivative of x is simply 1. What part we're solving for is the derivative of the inverse. And so we would divide away the, I'm losing my voice, the f prime of the inverse. Okay, so it's not as bad as it seems. Number one has a table, and they're giving us x values, y values, and then a derivative or slope at those x and y's. So it says the table below gives selected values for the differentiable and decreasing function, f and its derivative. If g of x equals f -1 of x, so if g is the inverse of f, what is the value of g prime of 6? So here's how simple I make this. We're trying to find, I still use f, we're trying to find the derivative of the inverse function at 6. I just always hate the notations of all this. It is simply 1 over the derivative of the inverse, oh, hold on, f -1 of 6. Okay, so you're going to do this part first. Well, if we're trying to find the inverse of 6, usually we have something like f of 6. 6 is an x value. This is now saying our y value is 6. What is our x value? So we want to find, where is y 6? Right here. What is the x then? -1. So now I've got 1 over f prime of -1. Now I'm simply finding that, and I'm finding the slope at -1, which is -3. So it'd be -1/3. Okay, so again, I'm finding the y value instead of the x, then I'm finding the slope at that x value. Right, and then number 2, we don't have a table, we have an equation. It's defined by f of x is -2x cubed minus x plus 3, and then point -1, 6 is on the graph of f. F to the -1st power is the inverse function of f, so what is the, you can't really see it, but the derivative of the inverse at 6. So again, this is going to be not an x value because it's the inverse, it's going to be a y value. And they gave us the point that when y is 6, x is -1. So my formula up there says it's 1 divided by the derivative of my inverse of x, or when is my y value 6 at -1? And so all I need to simply do is find the derivative of my function at -1. So I'm going to have to just do my simple power rule here. That would be -3 times 2 is -6x squared minus 1, and I'm going to plug in -1. -1 squared is 1 times -6 is -6 minus 1 is -7. But don't do what I do and forget that the answer is not -7. That's what this denominator equals. And so always having 1 over the value you get. So it'd be -1/7 is the slope of the inverse. So again, you are just taking whatever x they give you, really thinking, okay, this is a y, because the x and y switches in an inverse, using the x value to then get the slope of the derivative function.